with a little bit of a review of what we got into at the end of yesterday. We started to talk a little bit about amplitude, that number in front of my sine or in front of my cosine, which would take my base graph, the one that's in the dots, and stretch it, okay? And we found out it can stretch it negatively, positively, it depends. But we also hopefully saw, we're going to see here in a minute if you didn't, why it's easier a lot of the time to make a little bit of a dotted sketch of your initial or your base function and then just do the shifts from it rather than trying to redo everything with the calculator and wondering if things are right or not. So for instance, if we jump down here, and again we're on the page where it says example 5, so we're in the middle here. If you don't have a packet or misplaced it from yesterday, got some extras over in the folder if you need them. But what we're going to do here is we're going to take a look at this both with just doing shifts, and then we're going to double check it with the calculator. So on this first one, I've got my typical sine curve. And we talked before about you've got the base sine and cosine curves in the front of your note packet. And I really do think it's easier if you think about it once we get these guys labeled. Because again, like we did yesterday, we said, okay, now how do I figure this out again if I don't remember how to label all these axes in here, even though they're labeled for you on the worksheet? Remember, you can start thinking in degrees. It's okay to say, okay, this is 0, 2 pi is 2 times 180 or 360, and then say there's 1, 2, 3, 4 lines here. So if I take 360 and divide it into 4 equal parts, each part would be worth 90. And again, since you've got some room, if you want to, even jot this down a little bit further so it makes a connection later for you, that'd be okay, or maybe at the top. And then I got to turn this all into radians though, because again, we're speaking the trig language of love with this, which is radian. And so I remember, I'm like, okay, oh yeah, I can take this number, divide it by 180, and then reduce the fraction to be able to turn it into that if I don't remember what it is off the top of my head. So if I want to do the divide by 180, and I always want to be in fraction form, I'd be like, oh yeah, that's pi over 2. And then it was pi, and our final one over here was 3 pi over 2. And we talked about how you could figure that out one of two ways. You can either take any calculator. Oops, not 360 though, Harty. That will not help me. 180. Because what we're actually doing, 3 pi over 2, is we're looking at each of these and saying, okay, so here I've got a pi over 2. And if I keep adding 1 each time, well, 2 over 2 is 1. And I can just keep adding 1 each time until I get to the end. And 4 divided by 2 is 2. Either way to come up with that works. And once I have it, my base graph for sine or cosine is the same every time. So for sine, plain old sine, it always starts at 0. And then for each one of my 90 degree or my pi over 2 parts, it goes 0, 1, 0, -1, 0 every time. So if you get an idea of how that looks, where you can just make a quick sketch of it, now when I go to actually do this, and I look and I say, okay, my amplitude is -1/2. What's that mean? It means I'm going to take the y value and I'm going to multiply it by the amplitude for each of those points that I've already made. So if I have a point at 0 and I multiply it by 1/2, it really doesn't matter because 0 times anything is going to be 0. So any place that that I had a 0, I'm going to go ahead and my new point's going to go through that same spot. It's not going to move at all. But for these other ones, for instance here my y value is 1. If I multiply that by -1/2, 1 times -1/2 is -1/2. So that's where my new y value would be for that point. Or when I get to 3 pi over 2, since its y value is -1, Negative 1 times negative 1/2 is a positive 1/2, which is, again, just between the 0 and the 1. And then I would just make my curve by connecting the dots. And I've made my amplitude change. So you notice how that can work, because I don't want us to be so gripped into the calculator that we're like, eh. Because again, I mean, the calculator, I got to remember, oh yeah, is it in radians? Because I have classes that are doing stuff right now in degrees, so whenever you come in, you better double check, because it may have been put back into degree mode. Everybody's going to be flipping them back and forth here. We saw yesterday how many issues we could have with the calculator if somebody, you know, turned it where the axes are off, or maybe you're not getting a y value out. There's all these things that can go wrong, which aren't going to happen if I just do it this way. But again, we'll go ahead, and I'm going to use 0.5 instead, just so you can kind of see what's going on here. And you're like, oh yeah, we got to change that too. Because it's more than just, and I see, oh yeah, like that. It's more than just that, because yesterday we even had to go back in to do the second window to get into the table set. We had to change this too. And yes, I'm purposefully trying to make you want to go away from the calculator. I don't know if it'll work with some of you, but I'm going to try. So I got to remember to do all that stuff. Then I can get to here and say, okay, I was at 0, 0, at pi over 2, because we talked about the decimal being the same. I was at negative 0.5. Then I was back to 0. Then I was up to 1/2. Then I was back down to 0. So I can do it both ways. No complaints either way. It's just, I got to get used to it. So if we do that on the next one, and again, it's just getting used to that base graph. I'm telling you, it's worth it. On this next base graph, get my ones and my negative ones here ready to go. And again, since it's kind of nice for us on the worksheet, we got this part done for us already. So I can stop and look and say, okay, so my initial graph starts at 1 for cosine and then goes to 0, negative 1. Nice thing is you don't get surprises with the base graphs. Whenever it goes to 0, up, down, down, up, and here it goes down and just back up. Okay. And again, I look at my asymptote, my amplitude. Now, if 5 over 2 kind of gets some of you, you're like, you almost start thinking like, was that slope? I can think of it in its decimal form for my own visual help. And then I'm just going to make the shifts that are involved. Again, the zeros are going to stay at 0, because if you multiply something by 0, it's 0. But all the rest of them, I'm going to take the y value, I'm going to times it by 2.5. So 1 times 2.5 would be 2.5. Negative 1 times 2.5 would be negative 2.5. And then the same over here, which just means this time our curve gets a little more of a loop to it. But that's what the amplitude's going to do for us. If the number's in front of your sine or cosine, that's what we're going to do with it. Now, I want to do probably one of these, yes, on this next page, because I'm not going to make you do this in an assignment, but I want you to be thinking this way when we're doing these. So as we flip over to the back of this page, we're going to take a look at 6a here. You're like, ooh, they're giving you the actual new curve, and they want you to come up with the function for it. You're like, oh dear, no need to panic. Because here's what we're going to do. First, we're going to look here and say, ooh, numbering's different. What are we going to be counting by in each of the lines for my y values? 2. Because I'm like, ooh, there's 4 lines and it's 8. So, okay, we're going to be counting by 2s. So get those labeled. This hasn't changed, so we'll leave that the same. But now what I'm going to do is I'm going to go ahead and I'm going to put the original sine function in here. So I got to think about this for a minute. I'm going to do this just off of memory. Sine starts at 0. Now with sine, let's see. Where does sine go next? Does it go up or down? Peek if you have to. When we head to pi over 2 for my base sine function, where do we go? Up, okay? So we go up to 1, and then it just does the little loop-de-loop, down to 0, back down to -1, and back up to here. And you're like, well, why are you putting those on there? Because I'm going to be able to look to see what's changed from my base dots up to what I'm doing now. And just like before, I'm not going to get a whole lot of help from the ones that go through 0. It's going to be these other ones. So I'm like, okay, I know it's going to be y equals. I know it's going to be sine of theta. I got to figure out what that amplitude number is. Okay, this isn't going to be hard. In my original graph here at pi over 2, it's at 1. Now it's at 6. What's my amplitude? 6. Okay, because here, even, I'm at -1. Here it's at -6. -1 times 6 is -6. It's as quick as that. So that's all. I'm just trying to get you to think a little bit with these. But again, it comes back to, if I got a grip on my base graph, it makes this easier. Now again, I won't force something like this on you. If I threw this on a quiz, it'd be like an extra credit question at the end. It'd be like, hey, here's this sine function. Can you come up with the actual description of it? Because I want to stick to the basics here. So okay, we're going to leave the fancy stuff there alone and get to our next bit of fun here. We are going to jump up to what we call the D parameter. Now we talked a little bit about that yesterday. Our D parameter is our up and down shift. Just like it's been with anything we graph throughout the year. Whether it's been a parabola, square root function, doesn't matter. The part that's hanging out at the end by itself is always going to tell us whether we're shifting our graph up or down. And just like before, you'll notice that base graph is there. We're going to have those values available to us. And I like putting the dots on them so I can remember, okay, those are the spots that are going to help me. And then I just got to follow the directions to get to my next spot. And again, you can use the calculator, but who wants to get into all this crazy business? So what do you think that -2 is telling me on letter A? Down 2. So I'm going to take each of my base values, they're y, and I'm just going to go down 2. Okay, oh, now are these? Yes, they're still by 1s. Okay, I got to make sure about that. I don't need to start doing goofy things. So we're just going to take each of these and go down 2. I'm at 1, I go down 2, down 2, down 2. So I've got the exact same curve, except now it's just moved down a couple of places. It's like a nice wave that you're riding here. But again, the key, having those base points to just move those off of. Because you don't want to be messing with the calculator and all these decimal values messing around. That's just too much time. Too much time, too much thought, too much craziness. So I'm hoping at this point I've gotten my point across on the necessity to have an idea of that base graph. I mean, it's not complex numbers. It's zeros and ones everywhere. It's just getting used to where they start. So, for example, B, we'll call it. What's my shift going to be? Okay, up 4. Because I see that +4 at the end. So again, each of my points, up 4, up 4. So you're like, ooh, they all change when it's the up or down, and that's true. You won't have any that are going to get to stay where they're at. Up 4, up 4, up 4. But then the fun starts. You're like, okay, so now we've done some things with A, done some things with D, now we get to put them together. Hence, we have an amplitude and an up-down shift. What do I do then? We're always going to take them in this order. We're always going to deal with the amplitude first, and then we'll deal with the up-down shift second. Now this one gets a little more interesting. Thank you. So what we're going to do is we're going to kind of take this in pieces. We're going to do a little mental work here, but we're capable of doing this. Okay, so I'm going to take that first point, oops, after I get my labels put in here. So I'm at 0. I'm like, okay, well, what's 0 times -1/2 going to get me? 0, okay. But then this means I'm going to go up 2. Okay. So if we're talking about what we're trying to get to here, as far as these go, my first job, call this job 1, is to multiply the y value. Probably should write the word multiply, because some of you are going to be like, xy value by -1/2, and then job 2 is to whatever answer you get, we're going to shift it up to. So we're going to do both parts. So that's what we did on this first dot. We multiplied 0 by -1/2, got 0 still, but then we went up 2, or added 2 to it and made our dot. So we can end up in all sorts of places, funky places here. So like on my next one, I'm starting at 1. Okay, 1 times -1/2 would put me at -1/2, but I'm not going to put the dot yet because I still need to do my second job, which is to go up 1, 2. So I can end up at halves here. And if some of you need to even look at this and do a little side work and be like, okay, so it's like 1 times -1/2 is -1/2 plus 2 is 1.5. And then make the dot. Oh, okay, then that's all right. But that's what we're doing here. I'm just going to keep doing it with mental math, though. So here, I end up back at the same place. If they both started at 0, they're both going to end up at the same place with the shift. 0 times -1/2 is 0. Plus 2. So these things aren't going to change the actual curves. It's just going to change the way they're at. Here, I was at -1. -1 times -1/2. Negative times negative is positive. But then I'm going to go up 2 from there. And then finally, here's another 0. It's going to end up at the same place the other 2 zeros did. And so the negative amplitude flipped my graph over and made it shrink a little bit. You notice the wave isn't as big. But then the 2 moved everything up from there. So you're going to see lots of symmetry with this. But again, the fractions can get to be a little hairy at times. It's going to happen. So we're going to do this one more time on this next one. But I'm going to go into cover-up mode for a minute. So here, our amplitude is going to be 1/2. So we're going to be multiplying the y value by 1/2. And since my d value is -1/2, so 2 jobs here. multiply your y value by 1/2, or 0.5 if you're going calculator route, and then shift it down 1/2 once you've done that. So I'm going to cover this for a minute. Play with this. Try it out. It can be scary, I know, but it's worth trying out. So while some of you are doing that, I'm going to do mine. Quietly do my thing here. So multiply that by 1/2 would put me here. Down 1/2 puts me right here. 0, multiply isn't going to do anything, so I'll just do my down 1/2 on each of those. At -1 times 1/2 would put me at -1/2. But then again, then I'm going to be down. And finally here at 1, I'd be in the exact same place I was here. 1 times 1/2 is 1/2. Down 1/2 puts me right there. Okay, so we're going to be if you're finishing up yours or have finished yours, you can take a peek, because I'll kind of explain where mine came from so we can see if we're the same or if anything else is going on here. Okay, at that first dot, since we were at 1, I multiplied it by 1/2, which would have put me back here to 1/2, but then I had to go down 1/2 from there. So I'm at 1/2 and go down 1/2 puts me back at 0 for my first one. So I notice right away I have another point down at 2 pi that's exactly the same. So I know these two are both going to be the same, so I'm just going to put my dots there. When I move to my second dot, which is at 0, well, 0 times 1/2 isn't going to move, so it's still going to be at 0. So I just move the down 1/2, put my dot. And I notice again, I have another one over at 3 pi over 2, which I'll get in over here. So again, I just move it down the 1/2. But then this was the one that was really interesting to me. We start at -1. We times by 1/2, which would put me at -1/2. But then I need to shift down 1/2. I end up right back where I started. That can happen. Won't happen to all the points, but it can happen to one in there, maybe a couple. And so then I had my dots down here, so I notice it's the same thing, except it's just not quite again as curved because of my amplitude being a fraction. But again, that's what we're playing with as far as the up, down, and shifts like that go. But my amplitude is going to take precedence on this. Okay. So amplitude first, and then my D, my up or down shift, is going to be last in there. So now, do I want to play with period today? Yes, I want to play with period. So that is where we're going to actually head next. Unless, if there's a question, I definitely want to take that on first. So do we have anything question-wise that we've got right now that we want to deal with as far as our up-down shifts or the amplitude goes? Because now we're basically through that first homework package you've got, and we're going to start playing with the period a little bit. Not yet. All right. Let's flip over here. We're going to skip past the example 8 page for right now, because that's the fancy come up with your own expression. We will come back to there if we get a little time. So now we are going to work our way up to what's called the B parameter, or the period. So remember, our period basically, most of the time, is going to be 360 degrees, or 2 pi. However, what we're going to start noticing is now there's going to be a value that's popping up in front of my theta. That's where my period's found. So whenever that happens, we're going to be dividing that 2 pi by this value, which is going to kind of squish things up a little bit. So here's how this is going to work. Now I notice also a couple of things. And we said before, we got to really be cautious when we get these graphs to see if anything's changed from the norm. Well, this one has. Notice now my 1's up there and here's 0. So things have been magnified here a little bit that I have to keep an eye on. So I look at that and I say, ooh, this changed too. So I look and I go, okay, I can get this done. To get to pi, I got 1, 2, 3, 4. Okay, so I remember the pi is 180. So just real quick, I'm going to make sure here. So 180 split into 4 parts is going to tell me what each part's doing. Each part's 45. So I'm like, okay, if each part's 45, I'm just going to give myself a quick little help here. And I can start doing it either way I wanted to again. I can say, okay, 45 divided by 180, I got 1/4, which is pi over 4. Then I do 90 over 180, which is a half. And you're like, oh, this is starting to look like some of the ones we've done before. 135 divided by 180 if I don't remember. And again, this can get done in any calculator you want. 0.75, I think that's 3/4. It is. And then I remind myself, oh yeah, it's pi over 4, it's 2 pi over 4, it's 3 pi over 4, that's 4 pi over 4, 5 pi over 4. Ooh, wait a minute, the next one's 6 pi over 4. Oh, I can reduce that. Each of those by 2. So that's where the 3 over 2 is coming from. And I get set. But you're going to notice the values that we're going to use for the moment here are still going to be the same ones we've been using all along. Because you'll notice at 0 and pi over 2 and pi and 3 pi over 2 and 2 pi are still the same base graph that we had before. So even if it changes the way it looks, I can still use that base graph. But here's what I have to do now. My new period is going to get squished in a little bit. Like, what do you mean? Well, if my period before was 2 pi, and now I have to divide it by this b value, this number that's in front, what that means now is this entire graph that used to take up 2 pi is now only going to take up pi space. It's going to cut everything in half. You're like, wait, what? So here's what we basically mean by this. And I'm going to show it to you in both places again. I'm going to show you on the calculator, and I'm also going to show you in here. But basically what it means, grab another card here, is that before, we'll kind of do a side-by-side because the calculator is not going to be able to help me as much as I want it to. So I'm going to do a sin here. I'm going to go to degrees for a second so you can kind of see how this works. So I look and I go, all right. So I've got one at 0. Pi over 2, what's that in degrees again? What's 180 divided by 2? 90. Okay. So 0, 90, 180, 270, my 3 pi over 2. And 360. Those are where my points are right now that I have. So what I'm going to do is I'm going to cut all those in half because that's how much this got cut by. So those same points are going to be there, except now those are the values at which I'm going to plot my points. So I go, okay, so 45, if I want to look at it, because we got to speak radian when we're graphing. I remember this. But I just want you to see where it's coming from. So this is pi over 4. So now my 0 will still be at 0. Okay, that didn't move. My pi over 4 now, though, is going to be where this value used to be. So before, 90 degrees is where this first one was. Well, now it's at 45. My next value that was at 180, okay, which is pi, now is going to be at 90, which is pi over 2. So basically you're taking this and you've cut it in half. If I take pi over 2 and cut it in half, I get pi over 4. So you're just going to divide all of these by 2. So if I took 3 pi over 2 and divided it by 2, I'm going to show you an either slicker way to do this in a minute, I'm going to get 3 pi over 4. You're like, how'd you get that again? Again, you have multiple ways of doing this. You can either make a degree chart, okay, do it like this. There's my 3 pi over 4. Or again, you always can cut a fraction in half. My 2 pi is going, oops, I didn't do my 3 pi over 4 yet, did I? And then 180, we know is just pi. So that exact same it went from big and wide like this to shrinking down to just 1. But that's how these work. Now, the fun thing here is, do I have to do this degree thing to get the values? And the answer is no. What I can do, because I wanted you to see where they came from first, the easier thing to do with this, to me, would be to look and say, okay, my old values, 0, pi over 2, pi, 3 pi over 2, 2 pi, because that's where they all were originally. If I'm going to cut them in half, if you're going to divide by 2, it's the same as multiplying by a half. And instead of playing the degree game, all of a sudden I have all of my new measures, and they're all in radians already. Okay, radian is a very fun language to deal with once you get it. I think that's a much easier way for you to go ahead and be able to graph these and be able to just look and graph it that way. If I wanted to keep graphing this one, I don't have to get cute and fancy anymore. All I've got to do is keep saying, okay, I got back to 0. The next 45 degrees takes me back down to here. The next 45, and then it goes back up, and then it's all the way back up to the top. So basically what it does is it does 2 complete cycles in what used to only be involved with 1. But I want to keep stressing the need to A, have a pretty good grip, did I just do a boo-boo? Oh, it's been so long. I don't know how to count lines. How many lines are there? 3, right? I can count. They're like, oh my gosh, it's not the typical ones. What are we going to do? We're fine. Because if we divided, we'd see it's 60. So it's 60, 120, 180. And again, it's like, oh yeah, I'm just going to keep doing it by 1 more pi over 3 each time. And I can get these. Again, without practice, it gets tricky.
What are the ones after the pi?
4 pi over 3 and 5 pi over 3. Because I just keep adding a pi over 3 each time, and they didn't actually reduce at all.
Oh, okay.
So when I'm going back to look at what I'm doing this time, I'm like, ooh, this looks kind of strange. And it does, because we're not used to seeing some of these in the places they're at. This is still here at pi over 2, just like it always is. This is still here at pi. This is still down here at 3 pi over 2, just like it normally is. Okay, none of my dots have moved off my base graph. It's just getting strange now because now these values are changing a bit, but it's not going to be that big of a deal. We're going to be able to mess with this and make it work. Because I look and I say, okay, how's this going to work this time? My b value is 3. Okay, so if my b value is 3, what am I going to do? Well, I'm going to take 2 pi and I'm going to divide it by 3. You're like, well, wait a minute though, that doesn't simplify anymore. That's okay. It means this whole graph is going to get squished into this little area. Not a big deal. Like, what do you mean it's not a big deal? Oh, trust me, it's not a big deal. Because here's what I'm going to do. I'm going to do it the slick way this time. I'm not changing. Notice my same points are still there. They didn't change just because these values turned into divide by 3. So here's how I'm going to handle it. You remember last time we multiplied everything by a half because we were dividing? These, they're the same base numbers we use every single time. That's what this base graph has given me. And when it's sine and cosine, those will be the same starting values used every single time. Because now when I go to squish it, since I'm dividing by 3, you just multiply everything by 1/3. And that will give you your new values to plot. Now I know some of you when you saw pi over 6 are in a panic right now. Because you're looking, you're going, wait a minute, Harty? I don't see pi over 6 anywhere on our graph. You're right. You're going to have to be patient for a second. It's going to show up. And notice I end up at 2 pi over 3, just like I'm supposed to. So I look at that and I go, okay, well, how am I going to graph this now? Because I get that this is still 0. I'm cool with that. Where's this pi over 6 coming from? Well, let's think about it for a minute. 180 divided by 6 is 30. That's 0. That's 60. You're like, oh my gosh, you're going to make me put another line in. I guess I don't have to put it in, but I can realize this is going to be pi over 6 is in the middle. So my first dot, my 1, is going to be up here because it shifted from pi over 2 over to here. It's squishing. What I had at pi before, now it's going to move over to where pi over 3 is. What was at 3 pi over 2 way down here before is now moving to pi over 2. Okay, so this is, see, that's why it's good to have that base graph, because I still had the pi over 2. I didn't even have to go searching for it. And then what I had at 2 pi now shifts over to 2 pi over 3. And take a look at how much we squished that sucker. Okay, the one that was originally at 3 pi over 2 moved here, and I can even put this in here if you want me to, is where that pi over 2 was at before. And that moved in on me. So here's going to be our game plan. So we still haven't done our left and right shifts yet, so I'm just going to look here. We're definitely good now in the entire day 1 packet. So the packet you got yesterday, we're ready to roll. Now let's see how much I'm ready to roll here on this next one. And you're also ready to roll on the day 2 one, 1 through 8. The only thing we haven't done yet is this left and right shift stuff. Okay, so the day 1 packet now can be completed. And in day 2, which you got today, you're good on 1 through 8, because the only thing we're going to have left to do tomorrow are those crazy left and right shifts that go in with these. Everything else is going to be good to go.